Okay, problem number 4 is quantity discount problem. We have annual demand, ordering cost given, and holding cost is 30% of item cost, and the price breaks are given right here. So let's start. Number 4, annual demand D is 600, setup cost is $10, and holding cost is 30% of item cost. Okay, so now we need to set up. The first step is to find the candidate Q. So Q range is 1 to 49. Okay, the price is $5. So our holding cost will be 30% of $5. So $5 times 0.3. Okay, so that will give you $1.50. So then we have to use the formula Q. So 2 times 600 times 10 divided by $1.50, and that will give us 89. From that, then we have to look at the candidate Q. So what is the candidate for this price break? And remember the rule. If the Q is greater than the upper limit, okay, then there is no candidate Q for that price break. If the Q is within the range, then you keep the Q as is. If the Q that you get is smaller than the lower limit, then you have to round it up to the lower limit. So in this case, since Q that we computed is larger than the upper limit, we have to just ignore that particular price break. The next price break is 50 to 249. Let me write it here, 50 to 249. And the price is $4.50. So you take $4.50 and multiply by 30%. So that gives us $1.35. So then you again compute the formula Q, 2 times 600 times 10. Now this time you divide by 1.35, and that gives us 94. And since 94 is right within the range valid for this price, we need to keep the candidate as just 94, no change. Then the next price break is 250 and above, or greater than or equal to 250. And for that, the price is $4.10. So you take $4.10 and 30% of that is our holding cost, and that is $1.23. Now compute Q again, $1.23, and this turns out to be 99. Now 99 is smaller than the lower limit. This is 250 and up. 250 is the lower limit, and this one is smaller than the lower limit. So our candidate is 250. You have to round it up to 250. Okay, now we need to compute the total cost for these two candidates. Okay, so candidate Q. First one is 94. Okay, and price for that candidate is $4.50, and H is $1.35. Okay, So now we have ordering cost. Okay, ordering cost is D over Q times S. So that will be 600 divided by 94 times 10. And that will give us 63.83. Okay. Now holding cost is Q over 2. This one is D over Q times S. Now this one is Q over 2 times H. So that will be 94 divided by 2 times H is $35. So that is equal to 63.45. Now to this we have to add the cost of the item. So item cost is your annual demand is 600 times your price is $4.50. So this will give an item cost of 2,700. So cost or total cost for Q equal to 94 is 63.83 plus 63.45 plus 2,700, and that will give us 27.28. Now we have to do this computation for the second candidate. So let me do it this way. For candidate Q equal to 250, okay, ordering cost is, okay, remember it is D over Q times S. So that will be 600 divided by 250 times 10. So that will be equal to $24. Holding cost is Q over 2 times H. So we are using 250 as the order quantity. So 250 divided by 2. Remember this, for candidate Q equal to 50, the price of the item is $4.10 and the holding cost is $23. So we have to multiply this by $23, and that will give us 153.75, and item cost is annual demand of 600 times $4.10, that will give us 24.60. Okay, so total cost for Q equal to 250 is equal to, okay, 24 plus 153.75 plus 24.60, that is equal to 2637.75. So we have these two. So if Q is 94, total cost is 27.28. If we use Q equal to 250, 2637.75. So this is the smaller cost. Therefore, EOQ is Q equal to 250 at a price per unit of $4.10.